welcome to Bio 3, second lecture of week 1. Today we'll talk about scientific method. Well, just give you a brief review of what we have learned so far. On Tuesday, we talk about the definition of biology, which is the scientific study of life. And then after that, we define what life is. We talk about the 7 characteristics of life. So today, on Thursday, we will talk about what does it mean, scientific study. How do scientists study life? Scientists use something called scientific method to study the nature. So we'll talk about what scientific method is today. So this is scientific method. Scientific methods start with observation. Well, and then after scientists discover something interesting, then they will form hypotheses to try to explain what they observe. And then after they make the hypothesis, then they have to test the hypothesis by conducting experiment. So they want to test the hypothesis to see if it is true or not by doing experiment. Then after experiment, they collect data and we call those the results. The results of the experiment, then they will analyze the data, analyze the result. Well, there are 2 possibilities. If you are lucky and the result of the experiment support the hypothesis, then what happened? Then the scientists will repeat the experiment. Keep on repeating the experiment. We keep on repeating the experiment until so many times until when they consistently get the same result, then they can form a theory, which means that, okay, the hypothesis is pretty much the truth, the fact. On the other hand, if the result is not consistent with the hypothesis, then what happens? The scientists will revise the hypothesis and then repeat the experiment. When it revises the hypothesis, the scientist can also revise the experiment as well. He can change the experiment and to make sure, and hopefully they will get the result that will be consistent or support with the, hopefully until they will get the consistent and support the hypothesis. Otherwise, they will have to go around this loop. If they keep getting data that is not supporting the hypothesis, then they will have to keep on revising the hypothesis or repeating the experiment or revising the experiment until they get to this point. Until they get to this point, then they will continue to repeat until they can form theory. So that's the way scientists do research. And that's why it takes a long time to do research. And funding is an issue nowadays because to do research takes a long time and it takes a lot of funding to buy equipment, to buy animals, to buy chemicals, all kinds of things, and also to pay graduate students, to pay postdoc to do it. So yeah, research is actually a big business nowadays. So let's talk about observation. What is observation? Observation is not just, okay, you can see it, then it is observation. No, it's not just you can see things. Scientists can use instrument to help them to make observation. For example, An example of observation is that after raining, then what we will see on the curbside, or what we will see on the curbside usually is that we will see earthworm showing up on the curbside after raining. So this is a form of observation. Hypothesis. Well, as I mentioned before, hypothesis is like this is a definition of hypothesis, a tentative explanation for the natural event. So after we see something interesting, for example, okay, we see that after raining, earthworm will show up on the curbside, then we can form a hypothesis to try, tentative is like trying to explain that. And the hypothesis can be wrong. The hypothesis can be wrong, but it doesn't matter whether the hypothesis is true or not, because we're going to use experiment to test them. Yes, personal experience can influence the hypothesis because we are human beings. No matter how objective a scientist is, we still have biases. This is our human nature. That's why personal experience can affect the hypothesis. Most importantly, the hypothesis is testable. Why? Because we need to form a hypothesis that we can use an experiment to test them. If your hypothesis cannot be tested by experiment, then it is not a good hypothesis. Then you have to revise your hypothesis. For example, you cannot say that after raining the earthworm becomes very happy. We cannot ask the earthworm, are you happy? We cannot test the earthworm whether the earthworm is happy or not. So this hypothesis, after raining the earthworm become happy, well, it's a bad hypothesis. So the observation, okay, after raining the earthworm come out, and the bad hypothesis is that okay, the earthworm become happy, that's why they come out. Bad hypothesis. However, we can form a hypothesis. It's like earthworm prefer we can say that the hypothesis is that rain improve the motility or improve the movement of the earthworm, or earthworm can move better under rain with wet environment. Okay, this is a better hypothesis that you can test. So what about inductive reasoning? What is inductive reasoning that I haven't talked about? Well, inductive reasoning, let me give you an example of inductive reasoning in the next slide, then you will understand what it means. So let me give you an example of inductive reasoning. In the last slide, we talked about we will see earthworm coming out after raining, and we see this phenomenon in LA. And then when we go to SF, San Francisco, we also see that earthworm coming out after raining. And then we go to San Diego, SD. We also see the same phenomenon after raining, earthworm coming out. And then we go to Hong Kong. We also see that earthworm coming out after raining. Because we repeatedly see the same phenomenon in different places, in all over the world, we see that earthworm coming out after raining, then we can form a hypothesis to explain that. In the last slides, we said that, what is a bad hypothesis? A bad hypothesis is like, earthworms coming out, earthworm love raining. Okay, this is a bad hypothesis because we cannot ask the earthworm, hey, do you love raining? Do you love raining? I mean, the earthworm will not answer this question. So a better hypothesis will be like an earthworm or earthworms in general move better in wet environment. So earthworm move better in wet environment. So this can be something that is we call testable. We can conduct experiment to test this hypothesis. So earthworm moves better in wet So this is what we call a hypothesis. But what about inductive reasoning? What is inductive reasoning? Inductive reasoning is actually this part here. This part is the inductive reasoning. It's like we repeatedly see the same phenomenon from different, in this example, in different city. Then we come up with the hypothesis to try to explain that. We call this inductive reasoning. Okay, after we form a hypothesis, we need to design an experiment. How do we design an experiment? We use deductive reasoning. Deductive reasoning is basically if-then logic. So this is an example here. If organisms are composed of cells, then examination of organisms should reveal cell. So let's go back to our previous example, earthworm and raining. How do we design the experiment? How do we design experiment to test the hypothesis? Remember, our hypothesis is that earthworm move better in wet condition. So how do we test it? Then we can say that if we put earthworm on a wet table, then earthworm move longer distance. If we put earthworm on a dry table, earthworm move shorter distance. If we put earthworm on a sandpaper, extremely dry and rough area, earthworm will move the shortest distance. So this is an example of if-then logic. So if then so if we put earthworm in a wet condition, then earthworm will move the longest distance. If we put the earthworm on a dry table, let's say, then the earthworm will move I would say medium distance. If we put it on, let's say, sandpaper, dry and rough, then you move the shortest distance. So this is what we call deductive reasoning.